So here we're going to look at the mechanism for an acetal formation. In a previous example, I did an acyclic version of the acetal, where here I'm going to do a cyclic version. And when I mention the acyclic and cyclic, I'm talking about the actual acetal piece, not the fact that the carbon piece down here is cyclic. And the difference between the two is for an acyclic version, you have two separate alcohols add. In the cyclic version, you're going to have two alcohol functional groups on the same carbon chain. The steps are the same, it's just you eventually have an intramolecular process in the cyclic acetal formation. So the first step of the mechanism, as before, was protonating the carbonyl. So the carbonyl is going to be protonated, and what we'll get is the structure here. We'll get the protonated carbonyl that is now more electrophilic. We essentially activated that carbonyl so that in the next step, we can have our nucleophilic attack. And the nucleophilic attack is going to be the result of one of those alcohol pieces adding to the carbonyl, and then the double bond moving up towards the oxygen, and we get the structure shown below here. Now at this stage, we essentially have a hemiacetal with the exception of the fact that it is still kind of protonated here. So we need to deprotonate that, and that's going to happen with one of our alcohols again. Usually your nucleophile can also act as a base when it's an alcohol or water. And so we're going to deprotonate that and get to our hemiacetal. At this stage, the reaction is going to keep going. In the previous example, we created a good leaving group here, which was water, and then we added our second alcohol. Well, this time we already have our alcohol within our molecule. So once we lose this piece here, that alcohol is going to attack to form the cyclic acetal. But before we can do that, again, we need to protonate our OH group over here, the hemiacetal piece, so we can eventually form our acetal. And the acid I'm going to use is the protonated alcohol we generated from the previous step. And what's going to happen is this oxygen is going to remove one of those hydrogens from our protonated alcohol. And what we're left with is this structure here. We have our protonated hemiacetal, this time on the OH group, so we can generate this leaving group that is water. And we're going to reform our double bond, our carbonyl, as we kick out that water group. And let me see if I can draw that a little bit better. There we go. So at this stage, we have our activated or more electrophilic carbonyl-like structure because of the positive charge, meaning it's more susceptible to nucleophilic attack. And the nucleophile that we're going to use is not a intermolecular process, but intramolecular. Our alcohol group on this is just going to form a bond to that carbonyl carbon, pushing the electrons up to the oxygen. And we essentially will have our acetal at this point, except it's going to be protonated. And so we need to eventually deprotonate in the final step to give us our final acetal. And just like before, the alcohol, our nucleophile, is going to act as a base in this scenario, giving us our product. The steps to this was the same as when we did the acetal, the acyclic version. It's just, again, there's an intramolecular second component as opposed to an intermolecular. The steps are just proton transfer, followed by our nucleophilic attack. That's standard when you add things to carbonyl compounds. And then once we do that, we need to do another proton transfer to get back to a neutral hemiacetal. That hemiacetal will then be protonated proton transfer to generate a good leaving group, water. And once that water leaves, we have loss of a leaving group. So loss of our leaving group. We get back to an activated or more electrophilic carbonyl structure that is then susceptible to nucleophilic attack. Our nucleophile in this case being intramolecular, that alcohol component there, instead of an additional alcohol from the starting material piece. Once we form our cyclic acetal that is protonated at this stage, we need to do one more proton transfer to get to our neutral product overall. Again, exact same steps as before, but this one got somewhat tricky because the second nucleophilic attack was intramolecularly instead of intermolecular.